Hello, all you fine math folks out there. We're looking at question number 21. That's part C of the 2003 grade 8 level Gauss. Okay. The sum of four consecutive whole numbers is a multiple of 5. Which of the following statements about these four numbers is always true? Okay. So we have to actually look at each of the statements. This isn't some question where we can just do a calculation and get our answer at the end. The sum of the numbers ends in a 5. I don't think that'll be true, just because you could have multiples of 5 either end in 5 or a 0. That's a nice divisibility rule for 5, and I think there's probably some way to get a 0 in there. The largest number ends in a 9. I certainly don't think that's the case. Smallest number is odd. That one may be a bit more. None of the numbers are a multiple of 5. I'm starting to think that one might be a good one. And one of the numbers ends in a 3. Okay. So let's see. What's the sort of the best way to go about doing this question? Things I'm noticing. We're talking about the sum of four consecutive whole numbers. So I might say, let's let the smallest one be n, and then the next one's n plus 1, n plus 2, n plus 3. With that n in there, I'm working with a very general set of numbers. Okay? All I know is n plus 1, n plus 2, and n plus 3. When I add them all up, which should be 4n plus 6, that needs to be a multiple of 5. Okay? But so, for example, n would be the smallest number. So if I could learn a little something about that n, then I'd know whether or not C might be the right answer, smallest number being odd. Other things we could try and do is we could take each statement in turn and do a little sort of guess and check work, start thinking of four consecutive whole numbers, and see if we can try and break those statements. So I think I'll probably try and do a little combination of both of those. Let's take a look. The first one, sum of the numbers ends in a 5. Let's see if we can break that statement. So to make that not always true, all I need to do is find four consecutive numbers that add up, give a multiple of 5, but that multiple of 5 ends in a 0, not a 5. Okay, that's all we need to do. If we can find any set of four consecutive whole numbers that do that, A can't be the answer, because then it won't always be true. Okay, so there's a little bit of logic we have to work through here. So sum of the numbers ends in a 5. Well, let's see here. Let's just take the first four consecutive numbers. 1 plus 2 plus 3 plus 4. That turns out to be 10. A is not the answer. Okay. This is a multiple of 5, but it doesn't end in a 5. Okay? We don't always get multiples of 5 when we add up four consecutive numbers, by the way. 2 plus 3 plus 4 plus 5, that's going to be 14. That doesn't end in a 5, but it's also not a multiple of 5. So while it doesn't satisfy A, it doesn't satisfy the conditions of the question either. Okay. So that's A. A is not the answer. So already we're down to 4 out of 5 possibilities left. That's a 1 out of 4 guess if we have to. The largest number ends in a 9. Well, hey, we have a multiple of 5 here, sum of four consecutive numbers, and the largest number does not end in a 9. B isn't true. Because if B were the answer, then 4 would have to end in a 9, and that just doesn't make any sense. So just with this first example, we're getting rid of a lot of stuff. Smallest number is odd. Well, no, 1 is odd. Okay, so that didn't quite work. None of the numbers are a multiple of 5. Well, that certainly is true here. 1, 2, 3, 4. None of those are multiples of 5. One of the numbers ends in a 3. Okay, so we ruled out A and B. We've got C, D, and E left. Okay, what can we do? Well, let's see if we can E. Let's see if we can tackle E. Let's just pick numbers that don't start with a 5. Don't have any 3s in them. So 6 plus 7 plus 8 plus 9. If we do a little experimentation, that's a 15 in there, that's a 15 out there. Anyone who plays crib will certainly know that. So none of these end in a 3, although the biggest one is a 9, but we already ruled out B. But none of these end in a 3, so E isn't the answer. Okay. Smallest number is odd. Well, hey, this isn't odd, so that means C isn't the answer. Since we've ruled them out, D has got to be the answer. Let's just double check. Does D work, at least in this case? Yeah, none of these are multiples of 5. Now, to see why D is going to be the answer, let's just look at it using some numbers here. Let's let n plus 1, n plus 2, n plus 3, and n plus 4 be our 4 numbers. Okay, if you had ruled out all the possibilities, you realize D is the only one, bubble in D and move on, but this is just some theory as to why D is the answer. So let's let these be our 4 numbers. Okay, n plus 1 plus n plus 2 plus n plus 3 plus n plus 4. If this is a multiple of 5, then we know that 4n plus 10 is 5k, for some k. It's 5 times something, because otherwise how would it be a multiple of 5? Okay. Well, what I can do is I can say 4n is 5k minus 10. Just rearrange this. And that's 5 times k minus 2. Okay? So 4n has to be a multiple of 5. But 4 and 5 are what are called relatively prime. They share no factors other than 1. Okay? So 5 divides 4n. But 5 is prime, so this is another way to say it. 5 is prime. So 5 divides 4 or 5 divides n, possibly both, but this one here is clearly a lie. So that means that 5 divides n. Okay? But that means 5 can't divide n plus 1. 5 can't divide n plus 2. No 2 consecutive numbers are multiples of 5. You know, every 5th number is a multiple of 5. So if n is a multiple of 5, that means the next 4 numbers can't be multiples of 5, and that gives us D. And that's a more theory-based way to look at D. Okay? So I think the fastest way to do this one is probably just to start thinking of sums that give us multiples of 5 and rule out A, B, D, and E, or A, B, C, and E. That was pretty quick. Okay? But, you know, if D catches your eye and you think, oh, geez, I sort of remember some theory about this, you can prove that D is the answer. So D is always true, and we can be very confident in that. Okay? So that's question 21. In the next video, of course, question 22. And I'll see you shortly for that one.